Hello, everyone, and welcome to our ECE373 object-oriented final project. We decided to do a parking system. We implemented a comprehensive parking garage management system, as we said, using object-oriented programming, which includes a map of parking spaces accommodating standard vehicles, oversized vehicles such as a bus, and electric vehicles with charging stations. And each of these different types of vehicles had different qualities about them that we intake information on and process them differently. It also includes subsystems for payment processing, citation management, and ticketing to ensure smooth operation and accountability. Essentially, just looking at the different sorts of use cases with an actual parking lot slash garage and processing, real world events based on our code. And we also, including that, is a barrier arm that controls the entry and exiting of the vehicles. It remains closed until all the fees and citations are paid, and also the fees and citations are generated based off of times of day, but we'll get into that in a little bit. And also, each user is identified by their license plate. And another thing not shown is that there is a mobile app where the user can check their fee, but we'll get into that later again. Here's a reference. This is a existing object-oriented project that contains a parking lot management. We looked at this for inspiration based on how to structure our class diagram and convert this idea into a real world, or convert this real world idea into actual code. Here's the UML diagram for the part of the project I was most concerned with. This is largely the parking ticket and also the lot staff, which can be a manager who oversees multiple lots and the operations of them, and also an attendant who is there at certain times of the day to dispense a ticket when necessary. Here's the life cycle of a parking ticket, which starts with the user approaching the barrier arm. And once the time of day is checked, if it's morning, afternoon, or evening, then the attendant is there to hand out a ticket and print it and activate it. Otherwise, if it is nighttime, a kiosk generates the ticket. Once the ticket is created, it has a unique ID and it is considered activated. And we have here a loop for time passing with fee calculation and certain fees per hour depending on the time of day. And when the user is ready to leave, we have the fee finalized. They have added their payment method, and once the fee is paid, the ticket deactivates. Here we have a use case diagram with the attendant issuing the tickets. And as you can see, the automated parking system has a lot to do with the operation of this, such as checking payment status, calculating the prices, and then we have the driver who checks the payment status themselves on the app and makes the payment. Here we have a sample execution. I wanted to incorporate different exceptions, such as an invalid ticket ID. As you can see there, after the time has passed, and then we have the amount of time that they were parked for, as well as the fee. As we'll see later, the formula we use for that, the method of payment, and once that payment is properly exceeds the fee amount, we have the ticket has been paid and deactivated, and that initiates the opening of the barrier arm. And here we have the relevant code, which is the calculation of the total payment that's due from a parking ticket and a random bar.
All right, hello everyone. I'm Sam, and for this UML diagram, I implemented a payment system along with a barrier arm. This means that basically when a car pulls up, the barrier arm will open and you will enter the parking lot. And if you stay in the parking lot for too long, you will get a parking citation, and all this will be uploaded into this payment system. And when you try to leave the parking lot without paying your parking citation, the barrier arm won't open. Here's an activity diagram to represent this. You're going to enter the parking lot and the barrier will close behind you. We're then going to update the payment system with things like your name and your license plate number. Then going to check this timing threshold. If you don't pass the threshold and you pay your parking ticket, which is different from the citation, by the way, the barrier arm will open. You'll be allowed to leave. Once you pass the threshold, we're going to determine the time of day, which will make your parking citation fee more or less. And then we're going to check your payment status. And once you pay off your parking citation, the barrier arm will open and you'll be allowed to leave. But if you don't, we're going to display a failed payment, and we're just going to loop back to the check payment status. Here's a quick use case diagram for the barrier arm. Our entities are the car and the sensor. The car is responsible for things like opening the gate and making payments. You can think of the car as the user, and the sensor is responsible for opening, closing, and monitoring the arm. Here's a sample execution of this whole thing. Obviously, the barrier will open and the vehicle can pass through. The barrier is closed, and now the car is in the parking lot. And now it will prompt for the license plate and the owner and the time of day. This is all information for your parking ticket, which will be put into the payment system. Then once you pass that threshold value, we're going to issue a citation with a unique ID and a fee, which comes from the time of day. Barrier arm will remain closed until the citation is paid. We'll prompt you for the ticket ID and your payment amount. If this amount is less than the fee, then the arm will remain closed, and will prompt you to enter this information again. And only if you match the fee or it is greater than, then the arm will open and your vehicle will be able to pass. Code to implement this is basically just a giant while loop. We'll ask you for the ticket ID. If the ticket ID matches the one that you entered, then we'll ask for your payment amount. And if your payment amount is greater than or equal to the fee on the citation, the arm will transition states and will break out of this loop. Else, we're going to stay in the loop and we'll repeat until a valid input is given.
Hey guys, I'm Alan. So for right now, this is my UML diagram. It have the version of it have the BlueJ version. It also have the handwriting version, and it have the conclusion of the parking management system, and it will break up to user and attendants. And then below user, it will have a parking space, and then check for the EV charger availability. And for the attendants, it assign parking space. Also, it will cancel the reservation. And also, it will manage the remove vehicle issue or not. And then for the remove vehicle part, we have the actor as a parking attendant, and the description for that is the parking attendant removes the vehicle from the parking space, making the space available. And for next, it's my state diagram. It's my handwriting state diagram version. And then you will see the reset if it didn't meet the requirement. And then for next state, it will be parking space occupied and also vehicle EV, sedan, or overload. And it also will pay for the park or not, and it will go to the vehicle map parts. So it basically it will check if the vehicle have the parking space or not. So this is the UML use cases and sequence diagrams, and then it shows that there's user system parking space, and then reservation for different parts. They are all work together. They have the combination for request reserve space, and it will also check the availability, and it will confirm the reservation and so on. For next part, here's my relevant code, the codes related to some of the parts I mentioned before, and those are just um, classes for parking space, vehicle, and also EV charger classes, and they will have a setter and getter for different sections. Also, we can, for example, we have the get license plate. It will return to the license plate and so on. Also, we will have a override string called toString. It will shows the vehicle license plate. And this is the one of the simple execution. If you enter the license plate, it will tell you uh the results, your vehicle is being assigned or things like that, and then the availability of the parking space. And for next, there are more simple executions. When you say if you want to remove your vehicle, if you say yes, then your vehicle is being removed from the parking lot and so on. So if you say no, your vehicle doesn't want to be removed, then your vehicle remains in the parking lot.
Okay, I'm Jun Xiangwei. Hi, everyone. And my part is for 5 classes, which have user, vehicle, EV, trucks, and bus. And you can see uh, the relationship between those classes. And basically, EV, truck, and buses are 3 subclasses of vehicle class. And you can see the attributes with the private and public sign. And this is what looks like in the BlueJ IDE. And for state diagram, I have 5 state, which is the initial state, register, vehicle added, paid, and parked. And it is important that user class need to check between each state, which for register, check if the user typed the ID and name and its balance, and then if it pass, it will goes to the next state, and if it not pass, it will like go back to the register state. And you can see between the vehicle added and the paid, it will check the payment if it's failure or not. And for the use case diagram, I have 2 actors, which is user and administrator, and there are 4 cases, which is activate user, add vehicle, update balance, and delete user, which user can interact with all of the cases, and the administrator will see the interaction between user and the cases in the backstage information. And for the sequence diagram, the solid line means that the users will interact with the system, and the dot line means the feedback of the system to the user, or the database to the system and to the user. So you can see that user can activate the account, and the system will check the user status and verify the initial balance, and then after it all work, the status of the user will be created, and the status will be updated by the database to the system, and then it will activate user and feedback to the user. And a vehicle check the user status and check the balance of user. It's same like the first step. And this is my activity diagram, which we can see that we can start in the beginning. And for the activate user step, we need to check if the user is created or not. And if it's not, it will go back to the activate user. And if it's created, the user can it will show that user activated, and then user can choose if the user want to add vehicle or delete the user account. If it choose the add vehicle, you can go to the next step. It's check the balance, and we will check if the balance is sufficient or insufficient. If it's invalid, you will go to the another choice of update the balance and then go back to the check balance to make sure that if the new balance is is valid or invalid. And if it's valid, you will go to the next step is balance checked, and then it will successful. And if you choose to delete the user account, and it will shows that the user account is deleted and goes to the end. And this is my relevant codes. Uh, the left one is the user class, which I have the state transition method to have the state of the user, and then I will go to the add vehicle. Oh, sorry. I will go to the add vehicle state, and then we can check that the state of the add vehicle, and then it's the update balance state, which is to ask the balance of the user, and then it's the delete user state, which is to make sure that if the user want to delete the account or not. And then for the right side, uh, the mother class vehicle class is for ask for the information of the the vehicle, and then check the getter and the setter of the license plate to make sure the information of the vehicle is typed. And then for EV and truck and bus, and those class will ask for some special information, like in the EV class there's a battery level, and in the truck there's a load capacity to make sure the information of the three types of special vehicles are typed into the system. And then that is my sample execution, which I type the name and then type the license number, and then it will tell me that my account is created successfully with the license number. And then just choose the type of vehicle, and I choose bus, and I type into the license plate of the vehicle, and then it asks me the special information of special attributes of bus, that it asks me the rows in the bus. I type 23, and then it gives me the feedback of the bus, which is have the license plate and the rows. And then you check my balance, which is $0. So he asked me to to update my balance, and I choose yes, and then I give $1,000 into it. And then LS asked me to delete my account. I said no, and so this is the result. And for future, after we implementing all the diagrams into Java code, and we will debug all the codes in the system, and then we will get a better displaying, which is like we are not like showing people's with the system with the blue J. So we will get better displaying, and then we will do the data analysis to make sure that our system is working in the for the public or not. And last, we will upload the all system into the cloud and check that if we can connect to the public network or not. So this is the conclusion.
For the conclusion, the parking system project effectively utilized the UML diagram, sequence diagrams, and activity diagrams to design and implement the functional parking management solution. And the project showcased key features such as user activation, vehicle management, and system updates supported by the relevant code and simple executions, while debugging remains an area for further improvements. The project demonstrates a solid framework for future work and advancement in parking system functionality. Thank you so much for having us, and it's an honor to be here. Thank you.